article today is regarding hemophilia. Remembering that hemophilia is another X-linked gene. Hemophilia is an X-linked recessive disorder, to be specific. And what this means is that the gene is going to be responsible for the condition is going to be on the X chromosome. And it's at the defective allele where we find the disorder to be present. So if you don't have a defective allele on this X chromosome, you will not be affected by hemophilia. Now, males, remembering, have an XY chromosome, and they are more commonly affected by this X-linked disorder because they only have one X chromosome. So with the single X chromosome, if it carries a defective gene, the male will develop a disorder since there's no second X chromosome to help compensate for this deficiency. Whereas females have two X chromosomes, and in order for a female to be diagnosed with hemophilia, they need to have two defective X chromosomes. If they only have one defective X chromosome, they are only carriers, and they typically do not show symptoms as the other X chromosome is able to compensate. So in this question, we have a father that is completely healthy. And so this is telling us that his X chromosome is normal, and the Y chromosome can't carry hemophilia. The mother, however, is a carrier of hemophilia. And we know this because one of her X chromosomes carries the defective gene, but the other X chromosome is normal, and she doesn't have any symptoms. So if we use the Punnett square analysis, if these parents have a child, the genetic contributions from each of the parents is going to be as follows. Now, if the mother has a normal X allele and the father has a normal X allele, they're going to have a healthy daughter. If the mother has a defective X allele, then they would have a daughter who is a carrier if the father is completely normal. If a father has a defective allele and the mother has a defective allele, then you would have the potential for an effective carrier of either daughter or son. Well, what if the father's Y chromosome meets with the mother's normal X chromosome? Then you would have a healthy son. However, if you have a mother with a mutated X chromosome and a father with the normal Y chromosome, then you would have a son with hemophilia. So first of all, we have to think. The question is asking us specifically whether or not we understand the inheritance to the probability of specific genders. So we know that in this question, we're wondering what the chances are of having a son affected by the disease. So we have to do a little bit of extra math. The probability of having a male with an XY chromosome is going to be 50%, and 50% would be for a female with two X chromosomes. Now, specifically, if the son is male and they inherit a Y chromosome from the father and one X chromosome from the mother, there's going to be a 50% chance that the son would inherit the mutated X chromosome if mom was the carrier, which she is in this case. So the answer here, you have to combine the probabilities together. You have a 50% chance that the offspring will be male and a 50% chance that the son inheriting the abnormal X chromosome from the mother is 50%. 0.5 times 0.5 is 0.25. Convert that back to percentage, and you have a 25% chance that a son would be born with a carrier or with hemophilia because mom is a carrier and dad is completely healthy.